Now, example number 4. Okay, let's solve another equation here using the square root property. X squared plus 2. Now, all in one quantity, all squared, equals 9. At first, my main concern now is that, is my equation here, this current equation, is it in ordinary form? You might think that it's not, however it is. The point here is that you have one perfect square. So if you're looking at the left hand side here, what I see is you have one square, but the square here is for the entire, the whole 3x plus 2 is being squared. So here I do have a perfect square. The 3x plus 2 quantity square is my perfect square. So I know I don't need to do any further work to bring my equation to the ordinary form. It is already in ordinary form. I have one perfect square equals a number. So now I'm ready to solve. My left hand side, I can just simply rewrite my perfect square without the square. So I have 3x plus 2 without the square. Okay, equals, on the right hand side, I have square root of 9 with a plus and minus. Okay, but then at this point, keep in mind, what makes this equation here in this example different from those equations we've had earlier in the earlier examples here is that we're solving for x still. So you're technically not finished at this point yet. We need to find out what the x value is. At this point, we only know that we have 3x plus 2 equals positive 3. Positive 3 here came from positive square root of 9. And the other equation we produced, 3x plus 2 equals negative 3. Okay? And so now, solving my equation, these two equations here, I need to solve for x. So, for my first equation, subtracting 2 from both sides, that gives me 3x equals 1, and then dividing both sides by 3, that leaves me x equals 1/3. Here it goes, my first solution. Now, for the other equations, what I can do, subtract 2 from both sides, and that leaves me 3x equals negative 5, then dividing both sides by 3, that leaves me x equals negative 5/3. And here it goes, my second solution for the equation. So once again, the point is we solve for x. So that's why right after you take the square root on the right hand side, you're not done solving for x yet. You only found an answer to 3x plus 2 equals plus and minus square root of 9. That's the whole point of this example number 4. So let's try to get comfortable with that type of problem again. In example number 5, we have a similar problem. We want to solve for x. Keep that in mind. We want to solve for x. Now my equation here would be 3x minus 4 all squared equals 8. So if you want to look, if you're trying to answer the question, is my equation here in the ordinary form yet? Yes, it is. It's already in the ordinary form. The only thing we have to do now is that we apply the square root property directly, and then later on we solve for x. So taking into account that my equation already in the ordinary form, what I can do is just simply on the left hand side where I see my perfect square, what I can do, simply write 3x minus 4 without the square equals to square root of 8 with a plus and minus in front. And so keep in mind, square root of 8 is, I mean, you can reduce square root of 8, but it's not, 8 itself is not a perfect square, so that you can take square root. And so plus and minus square root of 8, you can reduce the square root into plus and minus to square root 2. Now, I recommend that you go back and review your reducing root skill, because we need this quite often in this class. And so once again, square root of 8 equals to 2 square root 2. The left hand side is the same, 3x minus 4. At this point, what this equation means here, we did not obtain our final answer yet. We did not come to our final point of finding out what x equals to. But this equation so far is telling me that on one hand, 3x minus 4 equals positive 2 times square root 2. On the other hand, 3x minus 4 can also be equals to negative 2 times square root of 2. And so at this point, I have just produced for myself two sub-equations where I can solve for x now. So turning my focus on my first equations, adding 4 for both sides, to both sides, that leaves me 3x equals 4 plus 2 square root 2. Now the critical pitfall here is that we still do not know what 2 square root 2 is, even though we know there's going to be precisely some number equals to 2 times square root 2. But we still don't know what exactly that is, so I'm leaving that the same way it is. So what I'm saying here is the expression here is all in terms of square root 2. So whatever 2 times square root 2 is, you add 4 to it. And now my final answers, I'm dividing both sides by 3. So my final answer here appears to be x equals 4 plus 2 times square root 2 over 3. Now, keep in mind, this can entirely be just fine as a final answer. You have the quantity 4 plus 2 times square root 2 all over 3. Now, course compass, which is where you're doing your homework, course compass might prefer to write your final answer here as 4 over 3 plus 2 square root 2 over 3. These answers are completely all fine. They're just different way of how you writing it. But what I'm saying here is this later form I just wrote right here might be the preferred one in your course compass homework. Now, back to the other equation. I'm adding 4 to both sides, and that leaves me 3x equals 4 minus 2 square root 2. And then at this point, I'm dividing both sides by 3, and I end up with x equals 4 minus 2 square root 2 over 3. And here you're technically done finding your solution. Your solution for x. The other solution for x would be x equals the quantity x minus 2 times square root 2 all over 3. And in the course compass way to re-express it, course compass might want you to write your final answer as 4 over 3 minus 2 square root 2 over 3. Okay. Now, example number 6 here. One more example for you to see how you can use these problems here. How you can use the square root properties in your problem. So we would like to solve. Now, this time I have x plus 3, all quantity squared, and with a times 5 in front, equals negative 80. Okay, sorry about the screen. Okay, but this equation here, once again, we're going back to some of those equations that it's not already in ordinary form. So you need to bring this equation here back to the ordinary form. And so, what I see is I'm almost at the ordinary form. I see my perfect square. Notice the perfect square is just simply the x plus 3 all squared. The 5 is not a perfect. The 5 is not part of the perfect square. So I need to divide the 5 away. So dividing the 5 away, that gives me x plus 3 all squared equals negative 60. Now I have a perfect square. One perfect square, x plus 3 all squared, that is one perfect square, equals negative 60. What I can do now, at this point, square root property is going to come straight into the point here. The left-hand side, my perfect square, will become x plus 3 without the square. And then equals to, I have square root of negative 16 with a plus and minus. Okay, and here's one more problem where you're going to have to see how to take, where you're going to have to see how we need to take square root of a negative number. So now, square root of negative 16, just simply think about what is the square root of 16. The square root of 16 itself is 4, but square root of negative 16 is going to be the same as 4 with the I, so it's 4i. So square root of negative 16 is 4i, and you have a plus and minus. Okay? And then x plus 3 equals plus and minus 4i. So at this point, I need to solve for x. This final equation so far, this current equation so far is telling me that on one hand, x plus 3 equals 4i. On the other hand, x plus 3 equals negative 4i. And so it tells me that I have two separate equations to solve for x. So my final step here to solve for x is subtracting 3 from both sides of my first equation, and that gets me x equals -3 plus 4i, plus 4i, right? And that, so my first solution would be -3 plus 4i. My second one is going to be, once again, I'm subtracting 3 from both sides. That gets me x equals -3 minus 4i. And that is my other solution for this equation.